yet why exactly this door failed, but it is certain that the manufacturer will have to improve the door and resubmit it for further testing. An elaborate procedure as expensive as a family car, but it's necessary in order to provide protection against fires. The firefighters in Cologne can't rely on fire doors. Quite the opposite, in fact.
Changes to materials used in construction have a very big impact on the development and behaviour of fires. Fires in closed rooms that are more airtight are more dangerous for us firefighters. And that means we have to alter our strategies and tactics.
Things get particularly dangerous for firefighters when they have to evacuate people from burning buildings. 95% of people who die in fires in Germany die from smoke inhalation. That's why the men in Jürgen Arendt's team regularly train how to handle their protective breathing masks. The breathing masks aren't enough on their own when firefighters enter burning buildings. The smoke means there's zero visibility. That's why the firefighters have long used a basic aid to find their way back in poor visibility. They use a rescue rope, which marks the way. It's their only connection to the safe outside world. But the method they're trained in has its perils. A few years ago, a firefighter died in Cologne because he got tangled up in the rope. This is the private firefighting academy Heat in Düsseldorf. The firefighters here regularly train how to use the rescue rope. One of the course participants is Markus Klan from the Fraunhofer Institute for Applied Information Technology. He wants to develop the rescue rope further and equip it with GPS sensors.
We do very application-oriented information technology and research. We try to understand users' problems and working methods so that we can develop suitable systems.
Markus Klan has already had some experience with the fire brigade in Paris. That's where he got the silver helmet from. Today, the Fraunhofer scientist wants to observe how the firefighters communicate with each other on the job. A fire is ignited in part of the test compound, from where smoke then travels into the exercise containers. Markus Klan accompanies the firefighters. The air supply is closed off. That causes more and more smoke to develop inside. The rescue rope is the only connection to the outside. Inside, there's thick smoke and poor visibility. The firefighters are following the rescue rope of the first team up some stairs on the first floor. Here it becomes clear why the use of such a rope is as dangerous as it is indispensable. A firefighter has stumbled over the rope in poor visibility, but his colleagues are able to find him.
We've just seen a classic problem of getting muddled around objects, which has led to several cases where people have struggled to overcome breathing difficulties. If you use the rope as a way to secure your way out, you have to keep it taut to prevent it from getting caught. It gives you the fastest route of retreat, and the safety team can get to you if you need rescuing too.
The long-established rescue ropes have a further flaw. They only mark one route for the team. If there were intelligent rescue ropes equipped with GPS sensors, then the information from several ropes could be combined. Scientists are already working on that. The Fraunhofer Institute for Information Technology in Bonn. The scientists here have developed such an information system. These are the rescue ropes of tomorrow. The working group around Markus Klan has developed a kind of navigation system. A special display, which can also be read in poor visibility, shows the way. The display provides information about the exact location, other teams and the safest route of retreat. This information is gathered by special GPS sensors. They have to become more fire-resistant before they can be used in fires. The system already works in virtual reality. Sensors mark the way. The information is immediately processed, fed into a navigation system and transferred to the display.
One of our big challenges is to make the systems robust enough to work reliably when exposed to extreme heat and physical strain. In addition, the firefighters have to learn to trust the systems. We're really working on the system's simplicity.
Can the firefighters work with the displays instead of the rescue ropes? An experiment will provide answers. The information on the display is set in this case. Because the fire-resistant sensors aren't working yet, the data only exists in the virtual reality world, programmed by Markus Klan and his team. But that makes no difference for this exercise, which aims to test how firefighters deal with the information.
The main challenge is that the work of firefighters takes place in an extreme environment. That's a big physical and mental challenge, and if we want to develop a navigation system, then these special circumstances have to be considered.
In a second scenario, they want to test whether the firefighters can understand the system quickly. They're confronted with a situation in which a rescue rope wouldn't help anymore.
Rauchausbreitung im Erstgeschoss, unklare Anzahl an Personen vermisst. Angriffstrupp zur Menschenrettung unter PA.
The firefighters at heat are working here too. Instructor Lutz Thieme explains how it's done. A problem is simulated that occurs a lot when rescuing people. At first, everything goes according to plan. The head of operations can follow his team's movements from the outside. The team finds the missing person and starts the retreat. Lutz Thieme gets the information on his display. Then, as often happens in a real job, there's a problem. They're cut off from the original route of retreat. Thanks to GPS data, the men can use the route of the first team and thereby find an easy way out.
We have firefighters from Heat who've tested this for the first time. They were very surprised at how well it works and what advantages it has, and even after the first prototype test, they were able to see that such a system, when fully developed, would have significant advantages for their work.
But nobody knows when the system will be ready and whether fire brigades can even afford it. At the moment, firefighters are mainly focusing on the fire engine, the most important tool. Firefighters pay close attention to what improvements manufacturers come up with, because the tasks are constantly changing. There are more frequent and more complex chemical fires, more big events, and more aircraft movements. Firefighters have to adapt.
The vehicles are categorized by their field of use. This purpose is determined by the location and how accessible it is. As a result, we have lots of different vehicles. We have small, basic, responsive vehicles, all the way to big, heavy vehicles to allow us to transport heavy equipment.
Airports are particularly risky. The fire brigade has more than 2,000 call-outs to German airports every month. Usually they don't have to put out fires. But they're training for this emergency because there's one rule for all big airports. Every spot of the airport has to be reachable within 2 minutes. A disastrous scenario would be if a large quantity of kerosene were to threaten lots of people in a small space. The Austrian company Rosenbauer makes special fire engines for airports. Among the special features are the pump systems for the hoses. Engineer Klaus Thornhäuser has been following the development of the Panther fire engine for years.
If I
were to give you the stats, the pumps that are used in airport fire engines can throw water for a distance of 95 meters from the exit of the hose to the source of the fire.
A normal fire engine can throw water up to 70 meters. The pumps of the Panther produce a much higher pressure. At the same time, they can switch from water to foam, and that's electronically controlled. The special vehicles cost around 700,000 euros and can do much more.
Airport fire engines have this pump and roll system where the fire engine can be moving at the same time as pumping out water.
The water leaves the hose at a pressure of 30 atmospheres. The high-pressure pumps are as strong as the water cannon used by the police. Unlike conventional fire engines, the pump has its own power source. That makes it independent of the two engines and can also be used while the vehicle's in motion, even at a speed of 100 kilometers an hour. The high pressure means the water can reach burning objects 95 meters away, even in headwind conditions. Many of the new technologies can make firefighting more efficient. That's why fire brigades are very interested in keeping up with current developments. But it's an open question whether Jürgen Ahrens and his colleagues will get the means to implement the insights of the fire scientists, because fire brigades are financially dependent on notoriously tight municipalities.